Hello friends, welcome back to my channel. Today I have come with the second chapter of Cbse class 10th Maths. That is second chapter is polynomials. This one is the continuation from the class 9th polynomials. We know that there was a chapter named polynomials in class 9 also, and here we are coming with other terms, the terms other than we have studied in the class 9th. And the polynomial in this chapter we will be going through the terms like degree of the polynomial and what is known as a linear polynomial, next one is a quadratic polynomial, next one cubic polynomial, etc. Okay, I think we have already studied what do you mean by a degree of a polynomial. We know that first of all we can go through the term polynomial. Polynomial can be represented as p of x. Okay, polynomial can be represented as p of x. Then p of x we can write as p of x is equal to I'm giving some examples here, like 2x plus 3. This one is a polynomial. Next example is, this one is the examples. Next one we can write 5x cube minus 4x square plus x minus root 2. This one is the next example for a polynomial. Next example I will give as root 3x plus 5. All the three terms given here is the example for polynomials. And first you have to study that class 9th. I am again going through the terms of the class 9 chapter polynomials, because this one is I have already told you that this one is the continuation of the polynomials. And here first term you have to study is the degree of the polynomial. Okay, what is the meaning of the degree of the polynomial? Degree of the polynomial. Here we can write the definition for degree as the highest power of x in the given polynomial p of x. Highest power of x in the polynomial p of x. We call the degree of the polynomial for the highest power of x in the p of x. Then considering this example, here I have given only one variable in this one. So here the highest power of x is 1. So the degree here is 1, right? And what about this one? This one the power of x is 3, 2, 1, and here it is no any term of x, that means x raised to 0. Okay, and here the highest number is 3, that means the degree is 3 here. Degree is 3 here. Okay, here the degree is 3, here the degree is 1, here also the degree, here 1. So the degree is 1. Okay, I will give more examples for the term. Here I have written another example for a polynomial. Here we can see that there is many terms with a u, right? The power here is 6, here the power is 4, here the power is 2, here the power is 1, and we know that the highest power here is 6, that is the degree of this polynomial. Degree of this polynomial is 6. Okay, and if this term is not here, the highest power will be 4 and the answer will be 4. Degree of this polynomial. Without this term, the degree of this polynomial will be 4. Next term you have to study in this chapter is linear polynomial. And what do you mean by a linear polynomial? A linear polynomial we can write as, I will give some examples here. Okay, 2x minus 3. Next one is root 3x plus 5, y plus root 2 x minus 2 by 11. Okay, in this polynomial, in these given examples, we know that here the degree is 1, right? The power of x is 1, that is the degree is 1 here. Here also the degree is 1. What about this one? Here the variable is y, so the power of y is 1, so the degree is 1 here, and here also the degree is 1. So we can tell that the linear polynomial is a polynomial with the degree 1. Polynomial of degree 1 is known as polynomial of degree 1 is known as a linear polynomial. A linear polynomial. Hope you understood this one. Linear polynomial is the polynomials with degree 1. Polynomials with degree 1. Okay. Next term you have to study is the quadratic polynomial. We have already studied the linear polynomial is the polynomial with degree 1. And what about this quadratic polynomial? We can find out the degree of this one. What about the degree of this one? Here, this one is the highest power is 2. So, the degree is 2, right? Next one, here also the highest variable is y. The power of y is 2. So, the degree is 2. Here, the degree is 2, right? Here, power is 2. Here, power is 1. So, we have to write the highest power of x. That is the degree is 2. That is a polynomial with a degree 2. Polynomial with degree 2, a polynomial with degree 2 is known as a quadratic polynomial. A quadratic polynomial. Polynomial with degree 2. Here are the examples. Next we have to study what is known as a cubic polynomial, and consider these examples. Here the degree is 3. Here the variable in this polynomial is x, and the highest power of x is 3. That is the degree is 3 here. Here also the degree is 3. Here what about this one? X cube, x square, x raised to 1 and x raised to 0. So highest power here is 3. That is the degree is 3 here. Here also the degree is 3. Here also the degree is 3. That is a polynomial. A polynomial with degree 3 is known as a cubic polynomial. A cubic polynomial. Hope you understood this one. That is the degree. If in a given polynomial the highest power is 3, that is the degree is 3, it is known as a cubic polynomial. If the degree is 2, that will be a quadratic polynomial, and if the degree is 1, that will be a linear polynomial. Next topic we have to study in this chapter is 0 of a polynomial. I have written here, find p of x is equal to x square minus 3x minus 4 at x is equal to minus 1. That means you have to find out the value of p of minus 1. Then we have to replace this x by minus 1, p of minus 1. So, in this polynomial, in the place of x we have to write minus 1. So, substitute that minus 1 square, x square means minus 1 square, 3 into minus 1, minus 4. Minus 1 square is 1, minus 3 into minus 1 is plus 3, minus 4. The answer is 1 plus 3 is 4, 4 minus 4 is equal to 0, right. Next we can find p of 4. Substitute 4 in the place of x, that is 4 square minus 3 into 4 minus 4. 4 square, you know that 4 square is 16 minus 3 into 4 is 12 minus 4. 16 minus 12 minus 4, answer is minus 16. Here also the answer is 0. That means we have here what we have done is replace this x by minus 1 and 4, right? Then we got that by replacing x by minus 1, the answer is 0. By substituting x by 4, the answer is 0. That means p of minus 1 and minus 1 and 4 is the 0 of this polynomial. That is, if we are substituting these numbers minus 1, 4, some other numbers also will be there, that in this polynomial, in the place of x, substituting these numbers in the place of x in this polynomial, we got the answer 0. That means this one is the 0 of this polynomial. Okay, in general we can say that if k is a 0 of p of x, that is the polynomial p of x is equal to ax plus b, where x is the a is the coefficient of x and b is the constant term, then p of k, then substitute the k in place of x, p of k is equal to ak plus b is equal to the, if k is the 0 of the polynomial, here we have seen that minus 1 is the 0 of the polynomial, means we are substituting x by minus 1 and we got that answer 0. Similarly here also, if you are substituting x with k, the answer ak plus b, that is ak plus b will be equal to 0, ak is equal to plus b, going to the RHS side it will become minus b, then the value of k will be equal to minus b by a. Then we can write it as minus b by a, means minus of b is the, in this polynomial x plus b, in this polynomial b is the constant term, right, and a is the coefficient of x. So we can write it like this, minus of b is the constant term divided by the coefficient of x. That is, we can write as from a polynomial we can find out the 0 of the polynomial by using this equation, minus b by a, that is minus of the constant term divided by the coefficient of x. This topic is the geometrical meaning of the zeros of the polynomial. Here I have drawn one graph example for this one. Here this graph is intersecting the x-axis at 2 points only, right? One this point and here other point. That is, it has 2 zeros of the polynomial. Here this curve will be according to the graph drawn according to the values given to the polynomial, and that you don't have to plot here, you just want to find out how many zeros of the polynomials will be here. That is, here this one is intersecting the x-axis, this one is the x-axis and this one is the y-axis, and here it is intersecting at 2 points only. That means it has only 2 zeros of the polynomial. And what about this one? If it is like this, here also it is intersecting x-axis at 2 points, here also 2 zeros will be there. And if it is like this, here it is intersecting at only at 1 point, that means it has only 1 zero of the polynomial. And if the graph is like this, it is not intersecting at the x-axis at any point, that means no zeros is there, no zeros is there, right? And if it is like this one also, it is not intersecting the x-axis, that means here also no zeros will be there. So from the graph you have to find out the zeros of the number of zeros in from of the polynomial, and you have to check whether at how many points it is intersecting this x-axis, how many points it is intersecting this x-axis, and you have to count that. And if it is not intersecting the x-axis, if it is intersecting only the y-axis, it is not considered as the 0. It is considering as the 0 only if the curve is intersecting the x-axis. So you have to find out at how many points the curve is intersecting the x-axis. So that will be the number of zeros. Okay, next one is exercise 2.1. Then the first question you have, there's 6 questions are there, sub questions are given there, and in all the question you have to find out the 0. There are some curves and lines are there, and from that you have to find out the number of zeros. The question is to find out the number of zeros from the given graphs. Okay, in the first question we can find that this one is a straight line. It is not, I have already told you that if the curve is intersecting the x-axis, then only we can consider it as a 0 of the polynomial. And in this graph it is not intersecting the x-axis at any point there, that means that it does not have it does not have any zero, that is no zeros in the first question. And what about the second one? Here in the second question, this curve is intersecting the x-axis at one point, that means it has 1 0. And next one, here in the third question, the curve is intersecting the x-axis at 1 2 3. Here it is 3 zeros are there. And what about the fourth one? Here it is intersecting this curve is intersecting the x-axis at 2 point, that means it has 2 zeros. And next one is fifth question. Here this curve is intersecting x-axis at 1 2 3 4 points, that means it have 4 zeros. And what about this one? 1 2 3. 1 2 3. It has 3 zeros. This one is a simple topic. So again I am repeating, in order to find out the zeros from the graph, you have to find out whether the given curve is curve or line. If it is like this one also, this one is a graph, right? Is intersecting the x-axis at one point, it is also considered as a zero. So if the curve given if in a graph the given curve is intersecting the x-axis at any point, if it is intersecting the x-axis only, you can't consider the zero as if the curve is intersecting the y-axis. So you have to find out the number of points, at how many points the given curve is intersecting the x-axis. That will be the number of zeros in the given graph. So again I am repeating, in this today's video we have studied about the polynomials, the degree of the polynomial, linear polynomial, quadratic polynomial, cubic polynomial. Of the polynomial, again I am repeating, this one is the highest power of the given polynomial. Linear polynomial is the polynomial with the degree 1, polynomial with the degree 2. Quadratic polynomial is the polynomial with degree 2. And what about this cubic polynomial? Polynomial with the degree 3 is known as cubic polynomial. And we have gone through some examples of the linear, quadratic, cubic polynomials. And next topic we have studied today is the zero of a polynomial. We can find out the zero of the polynomial by substituting the given number in the place of replacing the x with the given numbers. And if after substituting, if we got the answer as 0, we can tell that the given the number we have substituted here is the zero of the polynomial. And in general, if k is a zero of the polynomial, p of x is equal to x plus b, then p of k, substituting if k is a 0, then we have to substitute k in place of x. P of x is equal to x plus b. Here a k plus b, it will become a k plus b equal to 0. Then the value of k will be equal to minus b by a. And the minus b by a means b is the constant term. Here a is the a is the coefficient of the x. So minus b by a is equal to minus of the constant term divided by coefficient of x. And the next topic we have gone through is the geometrical meaning of zeros of a polynomial. If the from the graph we have to find out the zeros of the polynomial. If the curve is intersecting the x-axis at any points, that will be the number of the zeros of the polynomial. And we have gone through the exercise questions also. Exercise 2.1 I have already explained this one. You have to find out the zeros from the given graphs. And if the curve given here is cutting or intersecting the x-axis at any point, that will be counted as the number of zeros of the polynomial. Hope you understood this section, and I will be coming with the next section in my next video. Thank you. Bye.